Hi children, today you are going to learn ninth class 3rd chapter, that is Elements of Geometry. Very easy and a small chapter in the ninth class, that is Elements of Geometry. Already we know what is the geometry actually. So you might have seen in your surroundings like a big constructions, dams, buildings, your school buildings or your house buildings are not temples. Yes, we have seen many big constructions. Yes, so this all based on like a size and shape. They have some size and shape and length, lines and angles. Based on this, they have constructed it. How to estimate the cost of the constructions? It's based on the wages of labor and cost of cement, cost of bricks, and the material which is required to construction. So, engineers they estimate the cost of construction based on area and the size of walls and the height of the walls, and also they go for how much materials they required and the length, the width. These all things will consider to the estimate the cost of the construction. So mainly here we have to discuss about the lines and angles and length, breadth, height, and some two dimensionals and three dimensionals. These all things. So we know what are the two dimensionals, like a square shapes, rectangular shapes. Okay, prism is a three-dimensional, pyramid is a three-dimensional, cube and cuboid, this will be in the three dimensions. So here in this chapter, if you read about the introduction about the chapter, you will be know it very clearly. In the textbook, you go through the textbook. There you go through the introduction about the textbook, so that you will be know what is about this chapter actually. So here I will, in the short way, what is helpful for us to complete the exercise, I'll give you the introduction only that. You want to know more about this, more about other than the exercise, then you have to go through the thoroughly to the textbook. So mainly let us discuss about the geometry. Geometry is a Greek word actually. It is divided into the two parts. First geo and metric. Geo in the sense earth, metric in the sense measuring and measure. Okay, measure. Then metric in the sense measure. This is a Greek word. So normally maximum mathematicians from the Greek countries only. So one of the famous mathematician who is known as a Euclid, namely known as a Euclid, and he is also known as a father of the geometry. Father of geometry. So, who is known as a father of the geometry? Euclid is known as a father of the geometry. According to this Euclid, so I will tell you everything. But before going to the introduction about this, you have to learn about the about lines, angles, point. What is point? What is line segment? What is line? What is ray? And what is angles? What are the types of angles? What is corresponding angles? Alternative angles? This all about this I have done already video. That video link I will keep in the description. You watch the video so that you can understand about what are the geometrical parts like. All the geometrical parts I have explained there. So here, according to this Euclid, so there are three unknown terms like which cannot be defined. We cannot define that. We cannot find out the unknown terms, we can say. So what are the here undefined terms? Undefined terms. According to the Euclid, there are three undefined terms. Undefined terms. Okay, what are that? Here, a line and a point plane. These are the three undefined terms according to the Euclid. This Euclid has written 13 books based on Euclid Elements. Has written 13 books on Euclid's Elements. Name of the Euclid Elements based on geometry. How many books he has written? 13 books written. According to Euclid, these are the three unknown, undefined terms, that is a line. We cannot find out the length of the line. We cannot find out the length of the line because a line can be extended both the ways infinite. And a point, we cannot. A point is a lengthless and breadthless. It doesn't have a breadth and it doesn't have a length. So, the point and also here plane. You can see a plane here. A plane is a set of infinitive points actually. A plane also undefined term according to the Euclid. So there are three undefined terms according to the Euclid, that are line, point and plane. So these are the main things which we use it. And according based on other than this, we have to learn Euclid Axials and Euclid postulates. Euclid Axials and Euclid postulates. Yes. So let us learn one by one what is Euclid Axioms and what are the Euclid postulates. Okay, here and yes, one is the first one, Euclid Axioms. Euclid's Axioms and Euclid postulate. Okay, then first one, the things which are equal to the same things are equal to one another. The things equal to the same things are equal to one another. Let me write here, things which are equal to the same things are equal to one another. Equal to one another. So, what is this? Let me give you a simple example here to understand this. Suppose if A is any unknown thing, if A is equal to B and here B is equal to C, then what you can say here, A is a thing, it is equal to B, and here B is another thing, it is equal to the C. Hence we can write here A is equal to C directly. Yes, the things which are equal to the same things are equal to the one another. If A is equal to B and B equal to C, then we can also write A is equal to C. If this thing A is equal to the B thing and this B is equal to the C thing, then we can also say A is equal to C. So the next, let's see that if equals are added to the equals, the wholes are equal. If equals are added to the equals, the wholes are equal. Wholes are equal. The wholes are equal. Suppose the equals are added to the equals, the wholes are equal. This you can take the geometrical examples or not take some constants example. Suppose here number 2 and here also number 2. If these two are the equals, if you add an equal number to these two, then their whole will be also equal. Then the whole will be also equal. So for example, let us take here there is a 2 centimeters of line. Okay, here also there is a 2 centimeter of a line. These two are equal line segment. Here there is a 2 centimeter of a line segment, and here also there is a 2 centimeter of a line segment. If I add one more centimeter here of a line segment, and I will add one more centimeter of a line segment, so their whole is equal to also equal. Their wholes also equal. If equals are added to the equals, then wholes are equal. So this is also Euclid Axioms. So next, this we can apply to anything, either geometrical or not real life situations. Okay. Okay, mainly we will apply these all to the geometrical related problems. These are very important, Euclid Axials and Euclid postulates. And if you go for the third one, if equals are subtracted from equals, the remainings are also equal. If equals are subtracted from equal, the remainders are equal. Yes, if equals are subtracted from the equal, the remainders, whatever the left things are equal, the quite opposite of the second one actually. Suppose if we take here there is a 5 and here there is a 5. These both are equal. If we subtract equal things from this 1 and 1, the equal are subtracted. So the remainders here 4 and 4. These two also will be equal. So this can be applied to the geometrically also. Yes. So it can be applied to geometrically also. So if the equals are subtracted from the equal, the remainders are equal. This you remember. And the next things which are coincide, the things which are coincide with one another are equal. With one another are equal to one another. Equal to one another. Equal to one another. Okay. Then here the things which are coincide with one another. Coincide in the sense that both are same. Coincide in the sense. See, here there is a one line segment and there is a one more line segment on the same. Here suppose AB is a line segment and CD is a one more line segment which is coincide with the AB line segment. AB is a one line segment and CD is the another line segment which is lying on the same line segment. This is called coincide lines. That means both are same. If both things are same, suppose ABC triangle and X, Y, Z triangle. Both triangles are the same, coincide triangles. You can say that these two triangles here, two line segment here, two triangles are same to one to other. See, one triangle and the other triangle also same because they are coincide. Suppose your 9th class textbook, take two 9th class textbook, keep one on another, then the two things are equal to one another. Yes, I hope you understood this. Let's go for the next axiom, Euclid axiom. Yes. Things which are double of the same things are equal one another. The things which are double of the same things are equal one another. So this and the sixth one also you can understand here. Things which are of in the sense half of the same things are equal to one another. Equal to one another. Simple. The things which are double of the same things are equal to one another. The things which are double to the same things are equal to one another. Suppose make it double here. Suppose I will take here 5 and here the thing also 5 here, and there is a one triangle here, and here there is a one triangle. Both are same triangles with the same length. Okay, and if I make it double into 2, then the holes will be also equal. Suppose this is 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter are triangle. If I make it double their lengths, the sides, if I make it double, it become a 2 centimeter, 2 centimeters, 2 centimeter of a triangle, and here also 2 centimeter, 2 centimeter of 2 centimeter of a triangle. If I make it a double, if I make it a half of this, and there also will be equal. Here the things which are double of the same things are equal to one another. The things which are halves, in the sense of 1 by 2 of the same things, then they are also equal to one another. Both are same. Here double, here half. And we have seen the equation that Euclid number 2 and 3 added and subtracted. Axioms number 1 and axiom number 2. When you things you added to the one another, there will be equal. If you subtract the things from one another, they will be also equal. So these two also same, like here you make it double and here you make it half. Both are same. Then let us go for, these are the Euclid axioms actually. We'll go for Euclid postulates. Now we go for the Euclid postulates. Euclid axioms and Euclid postulates both are important. So let us go for postulates. Euclid postulates. Here there are some Euclid postulates. Postulate number 1. There is a unique line that passing through the given two distinct points. Yes, there is a unique line. There is a unique line passes through the given two distinct points. So you take any 2 points wherever you take it. Here 2 points. Only one unique line will pass through the given these 2 points. But if I have given a 1 point, there are infinite number of lines will pass through the given 1 point. If I have given a 2 points, only one unique line will pass through the given 2 points. Yes. So there is a unique line passes through the given 2 distance points, but is 2 different with the distance points. Okay. Now we go for the second one. Here a line segment can be extended either side of a straight line. A line segment can be extended on either side to form a straight a line segment. You draw a one line segment. Suppose AB is a line segment. Suppose here it is a line segment. It can be extended on the either sides. If you extend this on the either sides to form a straight line. If a line segment, if you extend the other side, either side, then it become a straight line. It become a line. If you extend infinitely on the either side to this line segment AB, then it forms a CD as a straight line. It forms a line, not a line segment. If this line segment, if you extend some length this side and this side then it become a line, that was a straight line. This is what is saying. Now the third postulate, we can describe a circle with any point and with a radius, center and radius. Postulate number 3, to describe a circle with any center and radius. So if we have one center point and with some radius, suppose 1 centimeter of radius. Okay, take 1 centimeter radius on the compass and draw a circle. To draw the circle, definitely we require one center point and some radius. Then only we can describe a circle. Yes. Suppose 2 centimeter. Suppose 3 centimeter of a circle. So what we require? Minimum measurements, the minimum things we require to describe a circle. One is center, the other one is radius. This is what is telling in the postulate, Euclid postulate number 3. Then the postulate number 4, all right angles equal to one another. Yes, all right angles are equal to one another. Yes, all the right angles, right angle, left right angle. Okay, any right angle is this all. Suppose this a right angle. These all right angles are equal to one another. So thing is that if the angle between the two rays is 90 degrees, it is called right angle. Then all the right angles are equal to one another. So this is a Euclid postulate number 4. Then there is a Euclid postulate number 5. See, to write this is a big, but to understand is very easy. If a straight line falling on two straight lines make the interior angles on the same side of it taken together is less than two right angles then the two straight lines, if produced infinitely, sorry children, infinitely meet on that side on which the sum of the angles is less than 2 right angles. Yes. So, if a straight line falling on two straight lines, suppose, let me take two straight lines like this. Suppose line L, line M. These are the two straight lines, and one more straight line falling on these two straight lines. Suppose this is N. If a straight line N is falling on the two straight lines, making interior angles, it makes interior angles, angle 1, angle 2, angle 3, angle 4, suppose, makes interior angles. On the same side, it taken it together is less than 2 right angles. 2 right angles in the sense 90 and 90, that is 180 degrees here. So, here suppose if you take a sum of these two right angles, angle 1 plus angle 2, if it is less than, if it is less than 180 degrees, if it is less than 180 degrees, if we add the sum of these two angles, if you got a less than 180 degrees, less than 180 degrees, that means less than 2 right angles, then the two straight lines, these two straight lines L and M, you produce infinitely. If you produce these lines, what happens? See, if you produce infinitely, they meet. If you produce infinitely, meet on the same side. These two lines will meet on the same side with the sum of the angles is less than 2 right angles. If you produce this, it never intersects. It will be produced infinitely these angles. That means these two straight lines will never intersect here. But here they intersect, because here sum of these two interior angles is less than 2 right angles. Here it is more than right angles. And here we can conclude that here L is not parallel to M. If L is parallel to M, the sum of these two is equal to 180 degrees. It will be like this. Here line L and line M, if they are parallel to each other, if a transversal, one line is passing through on this, that's called transversal, then angle 1 and angle 2, the sum of the angle 1 and angle 2 will be equal to 180 degrees. But here you got less than 180 degrees, no? Here sum of these two angles, if it is less than 180, if you produce here, these lines will be intersected, because they are not a straight lines. That means they are straight lines, but they are not a parallel lines. If they are parallel lines, definitely you will get sum of these two interior angles equal to 180 degrees. But you are getting a less than 180 degrees. Which side? Here this side, you got more than 180. More than 180 degrees. Here it is less than 180 degrees. Which side will get less than 180 degrees? If that side, if you produce the lines, that straight lines, they meet each other. More than 180 degrees wherever you want. If that side you will produce, they won't intersect each other. And hence here you can conclude that these two straight lines are not parallel lines. That is what. If a straight line falling on the two straight lines makes a interior angles. Here it makes interior angles, 4 interior angles you got. And the same side of the taken together if you add the same side of the angles, if you got less than 180 degrees or less than 2 right angles, if same side angles you add it and together, if it is less than 180 degrees, if you produce these straight lines infinitely, they meet each other where you got the less than 180 degrees. Which side you got a less than 180 degrees? If this side you got more than 180, this side you got a less than 180, because if you get a less than 180 here, automatically it will be more than 180 only. Okay, we are not discussing about the more than 180 degrees. We only discuss about the less than 180 degrees. Which side you get the less than 180 degrees? That side, if you produce the infinitely, they meet each other. Hence, we can conclude that the lines are not, the straight lines are not parallel lines. If they are parallel lines, the sum of the interior angles we get at the same side of the angles will be equal to 180 degrees. So, along with this Euclid axioms and Euclid postulates, we have to learn about the one more important thing, that is conjecture. Okay, the thing next we have to learn about the conjecture. Conjecture in the sense it is a mathematical statement which is neither proved nor disproved. Okay, neither proved nor disproved is called as a conjecture. So about the conjecture, it is already there in the textbook. See. So here and in the conjecture, and about the conjecture we have one question in the exercise also. There I won't explain again. You have to listen here. The statement the statements which are neither proved nor disproved are called conjectures. Hypothesis, that means we cannot decide either it is proved or not disproved. Sometimes it may be proved or sometimes it may be disproved also. That kind of statements are called as a conjectures or hypothesis also, we can say hypothesis conditions like the statements which are neither proved nor disproved called as a conjecture. Then here we can conclude that again mathematical discoveries obtain start out as conjectures. Mathematical discoveries obtain start out of a conjectures only always. For example, I will also give an example. Here it is there. Every even number every even number greater than 4 can be written as sum of 2 primes. Every even number greater than 4 can be written as sum of 2 primes. Yes, is a conjecture. Here is this is the example of a conjecture. Okay, stated by Goldbach. Okay, this we can say one of the example of the conjecture. A mathematical statements are a statements which are neither proved nor disproved or called as a conjecture. Mathematical discoveries obtained start out of as a discoveries, that means conjectures only. Every even number, that is for example every even number greater than 4 can be written as sum of 2 primes. For example, every even, suppose even number 6, we can write a sum of 2 primes, that is 3 plus 3 6. Here 3 is a prime number and here 3 also a prime number. Every even number can be written as every even number greater than 4 can be written as sum of 2 primes. 2 primes, the sum of 2 primes. Okay, that are here. Let me take one more even number, that is 8 can be written as here 5 plus 3. Here 2 different primes we got. Here the same prime we got. In this case, it's not proved. In this case, it can be proved. That means here it's not 2 primes. Here we got only one prime number. Here we got 2 prime numbers. Sum of 2 prime numbers. Here sum of 2 prime numbers is 8. In this case, 5 plus 3 is 8. Suppose 10. 10 can be written as 5 plus 5. Here we did not use 2 prime numbers. We used only one prime number. The same prime number we added. So that we got 10. So every even number that is greater than 4 can be written as sum of two fracts. It can be proved. Some cases, see, 8 can be written as 5 plus 3. Suppose 12. 12 can be written as 5 plus 7. In this case, this is a conjecture, it is proved, this statement. And if you take a 14, can be written as 7 plus 7. In this case, we have used only one prime number. So in this case, it is not a, it is disproved. In this case, it is proved. So these kind of statements are called as the conjectures, hypothesis statements. Okay, I hope you understood the introduction about these elements of geometry. Just you also follow the about introduction about the lines and angles video, so that you can understand more clearly, and will complete the exercise number 3.1 in our next video. Till that time, keep smiling and keep learning. Bye.